winding down. I mean, it's winding down too fast for me and you. June 4th, that's next, I believe it's June 4th, next Wednesday already. That's the day of the 5th exam, right? Then June 16th, I think June 9th, is the last day of class. So June 4th, next Wednesday is exam 5. And then that following Monday, which is June what, 9th, that's the last day of class. And then the following Monday, I think June what, 16th? Help me out with my dates here. That's the final exam. It's almost done. It's almost done. All you have is exam 5 to do, and then prepare for the exam, final exam. Now I am going to do this. Since the last day of class for us is June 9th, in fact for the entire campus, I think it's June 9th. We are so accustomed to June 11th, which is that Wednesday, to have class, right? But classes are closed. I mean, everything's over. So what I'm going to do, I'm going to hold a special session on June 11th, that Wednesday. Just review for a couple of hours for the final exam. So guys, I'll send you out an email that you know, and I'll make reservations for room 106, I hope, before we meet at 4 o'clock to do that, because we need to get ready for that final exam. I have students again. I don't want to talk too much. I got so much to do tonight. But I've got so many students right here, and I know who you are. Like 88.9. That's a B. That's a B. So after that 5th exam, who knows? I hope it goes up, but it could go down. And then the final exam may determine after all what the final grade is. Let's hope, guys. Let's hope everything works out for us. Mr. Park, we may have to, Susan, we may have to send out maybe a little practice for them and maybe give them a couple points. I mean a couple.
Like extra?
I mean a couple, 2.
Okay.
Not 6, not 4. I was just thinking about 1. So I thought maybe we can give out 2 points and maybe have them to practice with something that may be on the exam and then turned into me or you, and we can look at it and just give them a couple points.
Okay.
Okay?
How many problems?
1 problem.
1 problem.
And
Okay.
I'll let you know what it is.
Okay.
Okay. So they can do it. And that 2 points may help, I don't know. But that's all you get, just 2 points. That may help you in your final exam. Guys, here's what I gotta do. I planned this, I think I worked on this most of the day yesterday. And Monday. Thinking about now, how can I get all this done, this trig done, and therefore I can start chapter 11, which is basically the end of the course by the time we get to chapter 11. Now I realize we have Monday, this coming Monday, right? We have class. So I got all of that to do. I had plenty of time Monday to do maybe chapter 11. Then your exam is that Wednesday of next week. And of course I've got a little time to do some things there because your test is only like an hour and a half on this test. So we'll get through everything that we're supposed to get through, okay? Now though, to get through what I need to get through tonight, guys, you're talking about busy. We are going to be busy. I appreciate my 4 o'clock session, my students who came in. These guys, and I'm hoping all of you guys, they have been preparing. I can tell by the questions they ask at 4 o'clock. They have been getting ready and looking at some of those review problems. Now what I did myself was this. And you know me, I can't do it too much tonight though. I always love to do a recap of what we were talking about. So guys, I am going to do this much. But I do want you to do well in your next exam and also on the final. The even odd properties. Just right quickly. Now, I know it's been a little time since we've seen each other. Can anyone tell me what if I wish? Sometimes I wish I could express this differently. Cosine of a negative x can be expressed as is cosine x. I get to drop the negative sign. Now, if you look back in your notes, the reason is, I'll put it right here, f of a negative x is the same as f of x. It's an even function. That's the definition of an even function. So cosine's gonna work out nice for us. Sine, if I take sine of a negative x, and I'm discussing even odd properties, guys, it gives you this. It's an odd function. Reason, definition for an odd function, f of a negative x, if you look back in your notes, is equal to the opposite of f of x. Is that true? So there's a definition for odd, which makes sine odd, and here, even. The last one I'm going to hold you responsible for is tangent. Tan of a negative x, and some of my students may recognize what it is it even or odd? Odd. So it's a negative tangent x. And that is again because f of a negative x for an odd function is by definition this, if you look back at your even odd definitions. Now, I'm not going to hold you responsible for secant, cosecant, cotangent. Okay? They also are either even or odd. I'm only responsible for three major ones. Now you say, Professor, let me go back to this one, guys. I'm going to put a comma here. Are you telling me if I saw this, question is cosine negative pi over 4. And many of my students will say, oh, that negative sign says you're down in quadrant 4. Is that true, guys? Am I down in quadrant 4? It's a negative sign, negative 45 degrees? Is that what it means? Negative 45 degrees, negative pi over 4? Yes. And then ask you to find the cosine. You say, wait, I got to think about cosine, which is x. Is x down in quadrant 4 positive or negative? Positive. What you can do without going through all that thought, since cosine is even, you can quickly drop that negative sign and not worry about the quadrant. Thank goodness, that's one benefit. Therefore, the answer directly is radical 2 over what? 2. That's a benefit. If I did on sine, though, as you can find sine of a negative pi over 4. And again, negative pi over 4 is down in quadrant 4. If you think of it like that, it's down in quadrant 4. What is sine down in quadrant 4? The y? Negative. So you say, Professor, the answer is going to be a negative. Of course, it's going to be a negative, and also I could apply the even odd, in this case odd property, and make sure I get the correct answer, which comes out to be that. So that's the benefit of that. Another big benefit for the exam next Wednesday, especially, is this. I brought this one in. I think my 4 o'clock session, we're asking about one of these that we just ended with before class. It says sketch, now watch carefully, one complete cycle of this function, f of x is equal to, Alexander, watch carefully because I may write down the same one we just finished up downstairs, or maybe a different one. A negative 2 cosine pi over 4 subtract 2x plus 3. Is that the same problem?
Yes.
Okay, the entire class needs to see this. Everyone needs to see this. Maybe your first exam question will be a graph, something like this. Guys, you guys who like transformations, go for it. Because first I'm going to rewrite, as we always do. First, inside, they call this the argument. Inside here, that should be turned around so the x term comes first. We've seen that many times. And then to bring this up further, I should do what? Get the x completely by itself. I factor out negative 2. That's where you might mess up. You've got to be very careful in that factoring. And you guys with me at 4 o'clock, remind me, was it 5 or 8?
Yep.
So if you use the distributive property here for a check, distribute negative 2, that takes you right back to this. Now, with all that said, if, and we'll give the choice up to you, if you do this through transformations, that means first you got to place the parent graph for cosine, which we all should know now what that one cycle looks like. Besides the parent graph, you got to reflect it through the x-axis. You got to vertically stretch it by 2. You got to reflect through the y-axis. You got to, what was it, shrink maybe? By a factor of 1 over 2. Good luck. And they call this a phase shift or horizontal shift, what, pi over 8 to the right. And then a vertical shift up 3. And you guys who showed me all those different colors when you do a transformation problem on the quiz or an exam, you're talking about the colors? I think we counted downstairs, there were 6 transformations here, I think, along with the parent graph. That would be madness, but it would work if you have patience. If you went through all those, it would work. Guys, we don't have the time. What am I going to do? What will I do? First, I'm going to take advantage of a little benefit here. Cosine has been identified as what? Even function, which says, back here, I may apply this. So in other words, that negative sign there, at this point, for that cosine may be dropped. And you're just left with this. Guys, we agree? Can we drop the negative sign? Thank goodness, cosine is even. That's a benefit. If you were doing transformations, that's one transformation less that you have to worry about. So that reflection through the y-axis is gone because of this. That's a benefit. Now, I think that's the only benefit, so now we've got to sketch it. They said, Professor, you still got some transformations to worry about. Well, yes, but I'm going to focus on this. We call this the argument. Guys, if I go back to my parent cosine graph that we've seen many times, did it start at 0 and end at 2 pi for the one cycle? So I'm going to have my graph here to do the same thing, be bounded by those same bounds, 0 and 2 pi, written like this. Then I'll go over to the side here and solve this. So guys, this is caught between 0 and 2 pi, just like my parent graph was. So you have to reflect back to your parent graph and see how we bounded it. And you're going to bound this one the same way. You got to solve this inequality. I'll do it on the side here. Got to solve for x. Divide everything by 2, no problem. That leaves me this. Top of the board here. Do not let me make a mistake. That's true, guys? That's division by 2. To solve for x, now add pi over 8. And you get, I think it was what, 9 pi over 8? You guys who were with me? Now look at this. This is like 0 on the parent graph. This is acting like 2 pi, the end of that cycle, on the parent graph. So I've got the initial and the ending of my graph I'm looking for. But there's some points in between. I think we started out with a 0 on the parent graph, ended at 2 pi. Also, I think there was a pi over 2, a pi, a 3 pi over 2, wasn't there? Yep. Then 2 pi. So I have some others to find. But at least I know where it starts and where it's going to end. So guys, let's do this to get the graph done fairly quickly and not go through all those transformations. And here we go. We're going to start at pi over 8. And we're going to end at 9 pi over 8. Now, watch carefully. My next point coming up would correspond with pi over 2. It's missing. I got to find it. My next point would correspond with pi. It's missing. Got to find it. And the final point would correspond with 3 pi over 2. It's missing. Got to find it. And Ignacio, you gave me a great response in the 4 o'clock session. Tell the class how am I going to find those that are missing?
We're going to do the period.
Find the period first, which is the ending of the cycle. Subtract the beginning. Guys, I think you end up with pi. So the period of the graph, of the cycle, is pi. Now do what with that to get the 3 missing points?
Divide by 4.
Now he says take that pi and divide it by 4. So p divided by 4, which in my case is pi divided by 4. And I'm going to call this, Ignacio, is that my spacing?
Yes.
I will use, from the initial on down to the end, I'm going to use pi over 4 and start spacing to find the missing points. And guys, I see a pi over 4 and I see a pi over 8, so let's come up with a common denominator, make it much easier on us. I think we change this to 2 pi over 8. Still pi over 4. And we're back to the initial and start adding, spacing by 2 pi over 8. So guys, if I add 2 pi over 8 at the initial, that's going to take me up to what? 3 pi over 8. Add another 2 pi over 8. I'm up to 5 pi over 8. Another one is what? 7 pi over 8. Yes or no?
Yes.
Now, do I have all 5 that I need? Now we're ready to graph it. Billy and class, let me do this right now, so you will not be confused. This is done. You don't have to worry about this any longer. We took care of it down here. That's done. All you need to worry about is this, that, and that. This means what? A reflection through the x-axis, which means my graph's going to be upside down compared to here. A vertical stretch by 2, and a vertical shift by 3. So we'll go up to 3 first, get that vertical shift out of the way. Right there, and just quickly do it this way. And I think during the 4 o'clock session, we said, okay, professor, that's done, so I'm gonna mark that out. Don't have to worry about that. Now it's supposed to be stretched by 2. Even if I stretch by 2, that means stretch from what? Stretch from 3. So eventually I'm gonna go up to what number? 5. And if I go down to 1. Get this ready for us. Guys, that's done. Now what's left? The graph should be upside down. And I'm doing a cosine graph, and you guys know what the parent cosine graph looks like. I think it starts what? Up at 1 and comes down. This one's upside down, so it should start where? Here, and go up to the axis. Finally up to 5 axis, and back down to 1. You guys agree? And will the one cycle look something like that? And there's your graph. I want to just ask you to graph one cycle. That's one cycle of the graph done. And look at this mess. I erased most of it. Yeah, I did erase most of it. It was really a messy function. But there's its picture, its graph. Shane.
A question just for graphing on tests.
Mhm.
Would you be all right with us graphing like that, or do you want us to put some kind of indicator of a vertical line for the beginning and ending of the period?
Oh, no. I got you. You want to do this?
Would
I
you
think
want
why you
that
might
at
want
all?
to do that. You just want to show me it starts there and ends over there.
Yeah,
No, don't put vertical lines. Why, guys?
asymptote.
I might think that's a vertical asymptote. Don't do that. Leave it like that. Okay? Now let's get the domain, the range, and a few more items here. Guys got the period. The domain, they want the domain on the entire function. These cycles repeat forever. The range though, no matter what cycle you're looking at, drops down to what, a 1? And goes up to a 5. Can't go wrong on that. Amplitude, described as the highest point the graph goes from its axis. I know it goes up to 5, but with the axis at 3 though, so it's a distance of 2, and you cannot miss amplitude if asked because it's always this number here. Always, that coefficient up front will tell you the amplitude on sine or cosine. Domain, range, amplitude, beautiful. Now, I will ask you, I don't know whether we had time in the 4 o'clock session, did I ask us to go through and find f of something? I don't think it did. Besides all this, the graph's done. Guys, let's choose 1, 2, 3, 4, 5. Let's choose one of those 5 points. At random, I'm going to choose, here goes, guys, 3 pi over 8. I'm going to find f of 3 pi over 8, algebraically. Alexandra, if the graph is correct, my graph is on 3, I think. So the answer is 3. Now, algebraically, can I get this to agree to 3? If not, something's wrong. Now, that means I gotta go back to the original, which was -2 cosine. Guys, the original, I think, help me out, I turned things around a little bit. Was it a pi over 2 here? Help me out. Pi over 4, what was it? In the original? Pi over 4? And then subtract 2, what, x? And I'm replacing x by this. And what, plus 3?
Yep.
Okay, now, Ignacio, I'm hoping, it's messy. I'm hoping if I can crunch this out, I hope the answer is 3. I think it was a 3? Yeah, 3. The graph says it should be 3. So it's -2 cosine, gotta be very careful. Guys, this is pi over 4, subtract. I could do a little canceling here. Make that what, 3 pi over 4? Plus 3. And this becomes a -2 cosine, help me out inside there. Is that a -2 pi over 4? Reduce down? Not negative pi over 2. I just reduced it down. Is that true, guys?
Yeah.
Better yet, since cosine is even, I can drop this negative sign if I wish. Which even helps more. Is that true? And then from the unit circle, that much, the x-coordinate cosine, up there, pi over 2 has a value of 0. So it says this, plus 3. Are you going to get 3 for an answer? Yes. And that's what the graph says you should get. And that's a little check, probably a little check on your work. You guys follow me on this? Now don't be misled. I love sine and cosine. You know you have 4 other functions out there. Secant, cosecant, tan, and cotan. So you're saying, Professor, could I do something like you just did here on your cosine graph if it had been tan? Somewhat. Or secant, or cosecant? Somewhat. We could have done that. Okay. Guys, any concerns here? Okay. I've got some handouts for you later on. Now, see what I've made myself. Oh, I've made myself a few notes here. Yes. Let's call this part B, I guess. Okay, I like to sketch this. This one will be easy. I need to point out something to take me right into where I should be. Guys, I like to sketch this function, much easier than the one we just did. F of x is equal to, oh boy, let's see, what do I want here? Hang on. Why not? Watch carefully. Just that. That's all I want, just sketch of that. Now, I see only maybe, I'm looking like maybe a couple of transformations to be done here. I'm gonna do it through transformations this time. To simplify this, let's rewrite it as this first. What else should I do to sort of simplify this or clean it up? Take out the negative. So right, this is cosine. Take out the negative, and that gives me that. I'm doing this for a reason. May I drop the negative sign?
Yes.
Cosine's even. I love that even property. So the negative sign has been dropped because cosine is even. Now, before I graph it, we're ready to graph it. I'm supposed to take the parent graph. I'll take the parent graph. I'm going to do it through transformations. There's only one transformation. It's what, a phase shift or a horizontal shift to the right? Pi over 2. So I'm going to graph this one through transformations. But before I leave it, can someone tell me, suppose this had been sine, which it wasn't, sine right there, and sine with this, right? Would I be allowed to drop the negative sign if this were a sine function?
No.
Where would the negative sign go? Out front. That's back to that definition for another function. Guys, this one, I need a conclusion. That's what leads me to where I should be here shortly. This is a good lead-in. Watch carefully. I'm gonna place the parent graph and do that phase shift or horizontal shift, and that's the graph. Cosine, we just talked about cosine. Parent graph, 0, pi over 2, pi, 3 pi over 2, 2 pi. Goes up to 1, down to a negative 1. We start here, drop down. Please don't let me mess up the cosine parent graph. Here and here. Do you guys agree with that? Does that parent look something like this? The truth?
Yep.
Yep. Now, one transformation. It says, please now horizontally shift it pi over 2 to the right. Now, don't let me mess up. That means 0 is going to be shifted over pi over 2. So now it's here. Is that true? So is the graph now starting here?
Yep.
Next pi over 2, which I almost erased there with my finger. Next pi over 2 is also being shifted over pi over 2. Everything's being shifted to the right, pi over 2. So now pi over 2 is being shifted over pi over 2. Will that take me there?
Mm-hmm.
So is that going to place my next point in red to be this? Pi is being shifted over pi over 2. Will that take me to 3 pi over 2?
Mm-hmm.
Almost like that spacing we were doing over there. And guys, is that going to be down here? Don't let me mess up. 3 pi over 2 is being shifted over. That's going to take me over what? 2 pi? 3 pi over 2 plus pi over 2, everything's being shifted over. And should that be now here? Finally, though, I have the end of this, 2 pi, which I have not shifted yet. Where's 2 pi going to land? 5 pi over what? 2. When I add pi over 2 to it. 5 pi over 2. And please tell me, should it be, where should it be?
1, 1.
1. Is that true? Connected? Is this, by transformations, a quick sketch to represent this? Did I do what the transformation said to do? Only one transformation. Shifted over pi over 2 to the right. Now let's see if I'm ready. Okay, someone's going to help me out by responding. That's beautiful. Beautiful. Now you know the cycle is going forever. I'm happy right there. Could someone tell me if I were to take that red graph and shift it to the left? It's pi over 2, pi over 2, pi over 2. I can also go over to the left pi over 2. It says shift by pi over 2. I know it says shift it to the right, right? Mm-hmm. But is there, if this is one cycle, is there also a cycle over here somewhere? Mm-hmm. Is there a cycle over here somewhere? Mm-hmm. I'd like to, with your help, come up with a cycle on the left, because it goes on forever. I just have one cycle. Can anyone tell me what would be the next point over here if I want to get an additional cycle?
0, 0.
Is it 0? Is it 0?
Mm-hmm.
Next? Negative pi over 2. Okay, I'm going to do this. You want to do it in a different color? Hang on. So I'm going to put this out. We're going to put these, get ready for them. I may need more. Let's see if I do. Guys, please tell me, is this one going to be down here?
Yes.
Is this back on the axis?
Yes.
Back up to what, 1? And you're saying, Professor, if you want to do that, draw another cycle, which I think is supposed to connect. I drew another cycle. Conclusion? Who wants to be exempt from the test next Wednesday? Wouldn't that be nice? Just going to give your 80 points to you.
Sine of x is equal to.
Oh, hold on. Conclusion. I graphed in the black, this one. And you guys follow very well. Right? Conclusion?
That's equal to sine of that.
What is the red graph representing? I know we had a day off. Can anyone tell me what the red graph is representing? Which trig function of the six? That's sine. Are you kidding? By graphing, I'm saying these two are equivalent. Those two are equivalent. Would you guys agree? Let's look at the graph. So this conclusion right here, who on earth would think that those two are equivalent? We just showed they are by graphing. Did you follow my graph? Did the graph make sense? Bella?
How would that be explained in terms of the unit circle?
Here we go. I'll show you right now. Now, one way to explain what happened there, the graph says that they are equal, okay? But a good explanation is, guys, back when I first gave you the trig functions and their names, I wrote all of them down: sine, cosine, tan, cotan, secant, cosecant. And you guys accepted it as I would a student. I would just write those over. That's vocabulary. Now, you just give me vocabulary and he says, this is it. I'm gonna break this word cosine down for you. In the word cosine, yeah, I see the word sine. Guess what a CO means? Where they say cosine, cotangent, cosecant. I see sine, secant, cosecant within those, but what's the CO representing, I wonder? And it's a word that starts with CO, has the first two letters be CO, that I think you did way back in middle school. Name me a few words in math that start with CO. Shall we begin?
Coefficient.
Coefficient does, not the one I need here.
Complement.
Whoa, Ignacio. I heard coefficient, and I hope for more, but he says, Professor, I think this might mean, you did not tell us earlier, this might mean, tell me again?
Complementary.
Complementary. Does anyone remember anything from middle school about complementary angles? Sad. There's another word called supplementary. Does anyone recall what complementary angles are? That's what the CO represents. In cosine, the CO has something to do with complementary angles. Does anyone remember what complementary angles are? Alex?
Is it not like, compared to that, that's like 180?
Oh, if they add up to what, 180?
Yeah.
That's supplementary.
90.
Yeah, if they add up to 90, they're complementary. That's just vocabulary. So supplementary, if they add up to 180, which I don't need here. Complementary, CO, they add up to 90. Is pi over 2 representing 90? So there's my connection right there. Now the side here though, since Shane, that's one explanation. For an example, if I ask you the cosine of 10 degrees can be expressed as
The sine
sine of 80 degrees, as long as these two sum up to 90. That's why from the unit circle you saw this happening. Cosine 45 degrees, pi over 4, was equivalent to sine of 45 degrees. By the way, guys, is that true? Was cosine and sine of pi over 4 in the unit circle the same number? Why? They add up to 90. In other words, they're complementary. Now this cosine of, let's say, 6 degrees is equal to sine of 20 degrees is not true. They must add up to 90. They must be complementary for this to work or not. Shane, that's one explanation why that graph is showing me this. So graphing and then also that explanation about complementary. They call these functions cofunctions, CO. Also it works with cotangent and cosecant. CO, complementary. Now, here we go. This is gonna lead me right where I need to go. Part C. We're closing down here shortly. There's lots of formulas that you need to know for the trig. I'm gonna start out with this one. Cosine A subtract B. For a reason. Daniel, if I were a student, I'd say, Professor, no problem, it's this. No problem, there's no issue. Distribute the cosine. And I'm ready for Stanford. All of a sudden you show them at Stanford that, they'll say, well, no, you're not quite ready. Now, one reason is not. Let's try a particular example first. Guys, suppose I try this. Cosine, let's say pi over 4. Let's make it easier. Let's try pi over 3, subtract pi over 6. I'm just throwing numbers at you guys. Let's try that one for an example. A subtract B. Pi over 3, I think, is 60 degrees. Subtract pi over 6 is what, 30? So I'm talking about inside there for the argument. I can do this. This is the same as what, just this? Is that true if you put those two together? Inside there? Is that true, guys? 60 subtract 30? And cosine of 30 degrees from the unit circle is this. Now that, if this were the problem, this is valid. The way I approach this, that's valid. This makes no sense. Makes all kinds of sense there, the way we approach it. Now if you did this though, Professor, why don't I do it like this? Like the blue shows you above there. Just distribute the cosine. Now if I distribute the cosine, guys, cosine of pi over 3 was, help me out, 1/2. Cosine pi over 6? Radical 3 over 2. Answer looks like this. Same answers? Therefore, I cannot do it this way. In other words, I cannot do this. I wish I could. Just distribute, can't do it. Doesn't work. Now, what must I do? This is a start on formulas you're required to do. Guys, this does not work. You say, Professor, what does work? A formula that looks like this. Are you kidding? Are you kidding? You gotta know it. Now, did Ramsey show you a derivation exactly where that formula came from? No, but I've told you what you could not use. You cannot merely distribute cosine. It's going to take this formula. Cosine A, cosine B, plus sine A, sine B. Now I'm going to apply that to my problem here, and I hope to get the same answer we got earlier. Radical 3 over 2, I think it was. Yes, Bella.
Why does cosine parentheses A minus B and cosine A minus cosine B, what's the difference?
Beautiful, right here. Hang on now. We're saying this right here must be done by the blue formula. Bella, it cannot be done by doing this. Good question. It can't work. I tried it. I'm one of the problems.
But what is like the rational
I
explanation?
got you. Here we go. Now, if we accept it at this point, you say, Professor, if I accept that strange blue formula, which you just brought out as a formula for me, and I apply it, by the way, we know the answer here should be what? Radical 3 over 2 for this particular example, not this. Now, if I apply the blue formula, let me do it in blue. Alexandra, It says cosine A was pi over 3 in this problem, so it's cosine pi over 3. And next to it says cosine, almost forgot that, cosine of what? B, which is pi over 6, plus sine pi over 3, sine pi over 6. Alexander, did I get all that in there correctly? I know the blue looks a little messy, but I used what I think is the formula. It had better give me the answer. This time it better give me the answer, not this. That did not work. Guys, cosine of pi over 3, help me out. 1/2. Cosine pi over 6, radical 3 over 2. Sine of pi over 3, root 3 over 2. Sine of pi over 6, 1/2. Here goes, guys. This is radical 3 over what? 4. Plus what? Radical 3 over 4. They have a common denominator, so I could write this as what? 2 radical 3 over what? 4. Cancel 2 into 4 to simplify it. Please tell me, does that take me back to where I wanted to go? Bella, mathematician. I know what she wants. She wants a long, drawn-out derivations. And Professor, where'd that formula come from? Where'd that formula come from? I'm not going to show you where this first one came from. I'm going to show you where some of these others come from. We'll accept this one, and then I'll use it to show you others. Now, let me remind you, if back in middle school, your teacher asked you to find the area of a triangle, did you use a formula? Does anyone recall what that formula looked like back then? You said quickly, area is equal to what? 1/2 base times height. Remember that old standard formula? Does anyone in this accelerated class remember a middle school or high school student, teacher showing you where that formula came from? I doubt it. No. They said, there's the formula, and you accepted, you smiled, they smiled, and you saw it worked, and you accepted it. Is that true, guys? Does anyone remember the circumference formula from middle school to find the circumference of a circle? I heard what, 2 pi r? 2 pi times what, radius? Does anyone recall a teacher back then showing you where that formula came from? No, they were just lucky back then in the middle school that you just would know it. They didn't show you where it came from. Bella, so bear with me. I will not show you where this one came from. I think your textbook did. And they did it geometrically. They had 2 angles on the same grid. They had an angle A and an angle B, and they tried to add them and showed you what the sum would look like graphically if you add them up, and then found the cosine of that. And that's what their derivation was. We're going to accept this one though. With that said, hold on now, guys. Jeez. Shane, I have not forgotten you. Now, suppose I apply that blue formula back here on this original problem here. I'm going to apply now the formula, if I accept it, there on this. Applying the blue formula makes this what? Cosine pi over 2?
Cosine x.
Absolutely. Plus?
Sine pi over 2 sine x.
Thank you. That's the blue formula applied. I graphed it. Now, apply that formula. Cosine at 90 pi over 2 is 0. This entire first term drops out. Sine of pi over 2 is 1. I'm left with merely this. Not that. This. Is that true? Have I shown by formula that this in the black is equivalent to this? Did we also show on the graph they were equivalent? Is that true, guys? Whew. That's why I wanted to do the formula. To show you I could apply the formula and get that answer. So guys, please accept that cosine A subtract B, was it? Yes, A subtract B formula. And we use it. Oh boy, I gotta watch my time here. Oh, it's nice though. That's part C, formulas. And guys, I'm gonna label this as, this is my first one. Now what? Here we go. Number 2. What would happen if it had looked like this? And what cosine this time? A plus B. I'll derive this one for you. I'll do this one for you. I'll show you where it came from. First off, I saw a hand going up. Alex, was that you? You have an idea what the formula may look like?
Would it just be cosine A, cosine B?
I'm going now. Cosine A, cosine B, tell me more.
Minus
Minus
sine A, sine B.
sine A, sine B. He says, Professor, if you know this one, you'll know that one. It's just a sign change. Now, I will show you where this one came from. Alex, you are correct. That is the formula. Guys, where did it come from? Look at this. Could I express cosine A plus B as this? In the red. Is that still saying cosine A plus B?
Yeah.
As soon as I put that minus sign in there, I could go back and use this formula, because it was for cosine A minus B. So I could apply the blue formula here and write this as, be careful, using the blue formula. This is cosine what? A. Cosine how much?
Negative.
Negative B. Was there a plus sign or a minus sign down there? Plus sine A. Sine what?
Negative.
Negative B. What did we say cosine was earlier? Even? So can I drop that negative sign? So drop the negative sign, you have cosine A, merely cosine B. I got a sine negative B. Sine is an odd function. I cannot drop it, but I can do what?
Push it in front.
Bring it in front and write that last term as this. Would you guys agree? Alex? I think that's what you told me, right?
Yeah.
That's where it came from. Make sense? So if you know that one in the blue, you'll know the red one.
Is this only for cosine?
Hang on now. Whoa, 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 whoa. Hang on. Now, I know what she's thinking. She's a professor, you're trying to show us formulas here. I'm trying to talk as fast as I can to get all this done. Here we go, guys. Alexander. Another mathematician. We've got tons of mathematicians in here. She said, wait, Professor, number 3. Is there also a formula for this? Can I now turn to sine A minus B? You did cosine A minus B over there. And gave me a formula and we used it. Could I also do a sine A minus B? I can. I don't know whether anyone knows what the formula is for sine A minus B. I may have to derive another one here. Guys, anyone have an idea what it may look like? Trying to do all the formulas here. Mr. Hahn, what do you think it is?
Sine A,
Hang on now. Sine A.
sine B,
Go to it again?
sine B.
Nope. This one's strange. Sine A was a good start, but not sine B.
No, cosine
Sine A, cosine B.
cosine B.
Will it be sine negative B?
Cosine.
Hold on. Oh, I see if you want to derive this. Are you telling me maybe I could write this, hang on, as this? If I wish. I don't know whether it's going to help or not. Guys, are those two saying the same thing?
Yeah.
Yes.
Are they? Now what?
Sine A, sine negative B.
Okay, that's, okay. Oh, sine A minus sine B.
Well, I'm saying sine A times sine of negative B, which would be negative sine of B.
Oh, shit. I think you're telling me this.
It's just to.
I know what you're thinking, I know what you're thinking. Saying, Professor, I'm thinking this. I think,
Yeah.
you. But we don't know yet. Just trying, what you wanna give me is not what I'm looking for, but we don't know yet. Maybe I should derive this one. Oh, sine A minus B. Oh my goodness, Ignacio. I'm trying to think of a way to approach this to come up with what the formula is. And hopefully base it on something we did here. Jeez. Suppose I did this. Here goes, guys, I won't waste too much of my time here. Sine. Oh boy. Oops. Can sine A minus B be expressed as this? Now watch me run into trouble here. Are those two statements the same?
Yes.
Based on something we did earlier. Is cosine, it means what? Sine of the complement. So could I express this as sine of the complement or cosine of the complement, subtract this from 90? That true, guys? That would be like saying for middle school, a student has to find this, sine 15 degrees, and all of a sudden the student says, that's the same as cosine, what's it, guys, 75? Is that true? So I could write the complement range, I'm sure that it's going to be subtracted from 9. Is that true? Now let me regroup it. And write this as, I've got to be very careful, pi over 2 subtract A plus B. May I do that there to get that? Yes or no?
Yes.
Just play around with it. How's the breaker? Can I now think of this as, look at this mess. Can I now think of this as looking like, where was it, my cosine A plus B formula, where on the earth was it? Where was it? At the top? This is cosine A minus B. The way mine looks, I'm looking for a cosine A plus B type to work with. Where was it?
Bar number 2. Right above from where you were right
Over here. Oh, up here. We said this, right?
Yeah.
Guys? Did we got this one, right? Now can I apply this formula to this?
Yes.
If I'm careful. It says, should be cosine A, what's acting as the A down here? I over 2 minus A. That's the first part. Times what? Cosine B, yes or no? And for a correct here, so what? Minus sine A. I know this is a mess. I did not plan to do all this, but Bella was concerned. And sine B.
Sorry.
Bella, no way. That's what math is all about. I want this. You guys with that? Okay. Now, can anyone give me another name for this?
That's not a cosine.
It's actually, who said that?
Sine
Is that really sine A? Talking about cofunctions. Cosine, sine, yes or no? Of course, I got on the end this here. I got minus. Oops. What's a good name for this? Is that cosine A? Yes or no, guys?
Yes.
Sine B. Is that true? Now, if you follow this, I applaud you. Therefore, Alexandra, I have my formula, and I derived it as what, minus, was it?
Yeah.
Yeah, minus cosine A, what, sine B? Now he said, Professor, what is that? That's the formula you must use if they ask you on this. Sine A minus B. Mr. Hahn, you started me out with sine A, sine B. No, sine A, cosine B. And then a minus sign, and then cosine A, sine B turns around. Okay, guys, I'm showing you a little derivation. If you know one of these formulas, you'll know the others. There's a little sign change between them. So that's formula number, where am I? Sine A minus B is done with help of formula. Now, I'm not going to derive the last one. Let me erase. And that is this. Put it over here. Number 4. Can anyone tell me what on earth do you think, if you had to use it, what is a nice formula for sine A plus B? You solve sine A minus B through that strange derivation. What do you think the formula may look like for sine A plus B as your last formula? Sine A, cosine B, plus what? Cosine A, sine B. Do you guys agree? So if you know one of these, which I did derive, the one in blue down there, you'll know this one. A little sign change. Whoa. What a way to start eating class. Alexander, are there out there a formula for tan A plus B? There is. Am I going to do it? No. You have enough to worry about. Is there a formula, professor, out there secant A minus B? There is. I'm not going to worry about it. Okay. Guys, look at that. Now, what I am going to worry about, for all that work we did, is this. And then I'm going to leave it. Find this. The sine of 5 pi over 12. Now, you may be sitting there thinking, Professor, you had a day off. But you may be a little tired today. Didn't you make a mistake, Professor? Didn't you mean 5 pi over 6? Didn't you mean 5 pi over 6, Professor? You made a mistake. You put a 12 there. He's tired today. No, I'm looking for the exact answer for 5 pi over 12. Has anyone ever seen 5 pi over 12 on the unit circle? No, and you never will. 5 pi over 6, yes. 5 pi over 12, no. What are you going to do? Alex thinks he knows what to do here. He said, wait, Professor, I follow what you're doing here. I can find sine of 5 pi over 12, not from the unit circle, it's not there, but something to do with these formulas. Alex, what you got in mind?
Would you do add it?
Like, no, hang on, let me put it in a different color. Like, you want to rewrite as what?
You do like 3 pi over 12 plus 2 pi over 12.
Hang on now. 3 pi over 12 plus 2 pi? I think I heard. Is that true? Is that 5 pi over 12? Is it still 5 pi over 12? Oh my Lord. And by the way, better yet, Shane, I think Shane's going to tell me, Alex, you're right. Could I write it like this to make it look more like what we want? 3 pi over 12, would that not reduce down to this?
Pi over 2 minus.
And this? Is this pi over what? 6? Yes or no? What a good day today is. By the way, in degrees, guys, I think this is 75 degrees, if you convert it. Just out of curiosity, it's 75 degrees. I think this is what, 45? I think this is 30. So 45 plus 30 is 75. So I could rewrite it with Alex's help as that. Now, Shane, we don't have the answer yet. They want the sign of this. Please tell me, does this take the form of this?
Yes.
The sine A plus B. Do I have up here on the board somewhere sine A plus B formula?
Mm-hmm.
Oh, Lord, I hope so.
Directly above it,
Where was it?
just above where you write it at.
Right here, right above here, right there, staring at me. I can apply this formula. And if I do here, this becomes sine, what, pi over 4? Cosine, pi over 6. What is that, a plus sign? Yes, it is. Plus cosine pi over 4, sine pi over 6. Guys, make sure I use that formula right above there correctly. Is that true? Put my numbers in from the unit circle. This is radical 2 over 2. Help me out. I think this is what, radical 3 over 2? Help me out. Mr. Park, I'm going to ask you something here shortly. Radical 2 over 2. And I think this is 1/2. Is all those numbers correct? Let me unit circle. It did take me to the unit circle. Guys, this is radical 6 over 4 plus radical 2 over 4. Common denominator, just add them up. Radical 6 plus radical 2 all over what? 4. There's the answer. Now what does that represent? That's the answer for sine of 75 degrees. I think it's 75 we're talking about here. Mr. Park, now don't code, don't write a program. This guy's into his math, writing coding and all that. Mr. Park, could you just please find for me? Find sine of 5 pi over 12. You suit you, how do you feel a bit faster? Find sine of 5 pi over 12. Mr. Park, tell me what the screen shows.
Oh, it says it's approximately 0.96.
Whoa,
9659.
0.59?
Yeah,
I've
9659.
got it carried out. Now, we have an answer like this.
Okay.
Now, calculate what radical 6 plus radical 2 added up and divided by 4. What's this supposed to?
It gives another answer like exactly like that too.
So are you, Mr. Park, are you telling me, without that coding over there, are you telling me these are equivalent?
Yeah.
Okay, so it's the same. And we're gonna make this work. I'm about to leave this chapter. Guys, make sense with these formulas? Now, what's gonna be up to you, and somewhere on this handout, I think I have a handout tonight also has the formulas listed for you. You're going to have to find out what that formula looks like. Okay, so I've got 4 right now. Before we take a break, which is 5 minutes, some clever student, more formulas. Please stay on the other side here, guys. This is a start. I'm all over the board here. Now, suppose I'm looking for some reason, this. We'll call it theta. I need a formula for sine double theta. Actually derive it, see what it looks like. Then show you how to use it. We'll take a break. But see, one thing to have an idea of how to come up with on your own. Let's say you're taking a test and you've forgotten what it looked like, but you can derive it yourself. What could you do to derive it? Mr. Hahn.
Sine theta plus theta.
Look at this. He's made it now look like this. And since he's made it look like that, I have a formula for it. Go down to what? Sine A plus B? Geez, I got formulas all over this place. Is it this one again? Mm-hmm. I'm going to apply this formula to this. If I do, Mr. Hahn, no, let me make a mistake here. What I get? Sine theta, cosine theta, plus cosine theta, sine theta. Is that what the formula down there tells me is going to happen? On this particular problem? Yes, no?
Yes.
Are those like terms? Just turn around a little bit. Is this term, there's only 2 terms here, and this term, are they like terms? That's like back in middle school, the teacher says, put these 2 together. And I hope you say 2xy. 2xy. In this case, they are 2 sine theta, cosine theta. and you have, as if, we don't have enough, you have another formula you're responsible for. Right? Check my time here. I'm gonna do it, then we'll take the break. Ignacio, Mr. Mathematician. Could you help the class out with, put it in blue here, and we'll take a break. Could you help the class out with, just in case I need it later on, is there a formula for cosine double theta?
Yes.
And also give me a start on how could I derive it and actually find it myself.
We do cosine of theta plus theta.
Beautiful. Now, since he's done that, guys, he's put this in the form of cosine A plus B. Which I think, let me check and see if it's still here, is it this formula? I'm gonna apply this formula to what he just gave me. Now see, tell the class what that would look like, apply the formula.
Be cos theta
Cosine A, theta,
times
Theta.
cosine theta. So it would be cos squared theta, right? Because it's two of them.
cosine theta again,
Yeah.
okay?
Minus sine theta. Sine theta.
Look at that. Absolutely, that's what it looks like. It looks strange. Now, I could write this as, the first term could be rewritten as cosine squared theta, that's from algebra. And the last term, what, sine squared
Yeah.
theta? And now I have another formula. Really? This one's for cosine in case I need it. Double theta. Now, before we take a break, now I'm not showing you the applications of all these formulas yet. I could, sometimes it's wise, I could rewrite what Ignacio just gave us, which is a formula, in a different version. Does anyone see anything I could do with his version and rewrite it a little differently? Just out of curiosity. Could that be written just a little differently? Ignacio, this is one of the formulas on the handout that you're gonna get. I accept that 100%, but is there another version of it? Before we close down, Mr. Hahn,
2 sine theta
wait, tell me what you're gonna do. What are you gonna do with his red response there to come up with another version just in case I want to use it?
from identity.
Could I rewrite this? Let me get you started. Is there a replacement for cosine squared?
Oh, yeah,
If I did, was sine squared plus cosine squared equal to 1?
yeah.
Therefore, what would cosine squared have to be equal to?
1 minus
1 minus what? Sine squared. If I wish, and leave the one on end like Ignacio gave me, leave that the way it is. But Ignacio, on this one, if I do that, will your formula now turn into this? Now, what might be the benefit, even though I love this is standard, what might be the benefit, though, in thinking of it as looking like that? There's only one trig function now, just sine. The first one has 2 trig functions, which will work. And before we take a break, can someone tell me, I'm going to do it in black here, I think, let's see if I can come up with a nice way to do this. Is there a replacement for sine squared? Go back to his red formula and tell me, guys, I'm going to mess up here, is there a replacement for sine squared, just in case I need it? 1 minus what? Cosine squared. That came from what? Sine squared plus cosine squared is equal to 1. And leave his cosine squared he gave me out front, like it was. And I got that. Someone clean that up for me. What would that look like cleaned up? better cleaned up. Cosine squared. The negative sign out here, distributive would be what, -1 plus cosine squared. I just cleaned it up. Combine like terms, would I end up with this? 2 cosine squared minus 1. Now, doesn't matter which version, Ignacio, if you want to use this version, the class wants you to use your version, go for it. Or you may say, no, professor, with what's given to me in the data, it may be faster to use this formula or version. Or who knows, it may be faster to use this one. It's up to you. They'll all lead you to the same answer. We're supposed to take a break at what time? 6:10. Has that been the standard, 6:10? Guys, any concerns here? I think we've done a great job. It's just gonna be a big responsibility on you. I'm gonna sort of finish this up, and it's chapter 6. We're gonna say goodbye to it. So guys, take your 10-minute break.